Good morning to one and all. My name is M. Sai Gurukum. I am from CIS section. My roll number is 20BQ1A4735. Today my topic is magnetism. In magnetism, I want to say about the magnetism, types of magnetism, difference between the dia, para, ferro and antiferro, ferromagnetic materials and histories, organic of magnetism movement. Now, for starting, we have to know what is magnetism. The phenomena of attracting iron, steel, nickel and cobalt is called magnetism. Magnetism is force attracted by the magnets when they attract or repel each other. Magnetism is caused by the motion of electric charges. Every substance is made up of the tiny entities called atoms. The movement generates an electric current and causes each electron to act like a microscopic magnet. Magnetization and demagnetization. Shall we know about that? What is magnetism and what is demagnetization? Magnetization, conversion of non-magnets to magnets. Demagnetization, conversion of magnets to non-magnets. Shall we know about how many types of magnets in there in world? There are 4 types of magnets: natural, artificial, temporary and permanent. Natural magnets available originally in the universe. Example Earth. Artificial magnets prepared artificial by man. There are 3 types: bar magnet, die shape and horseshoe magnet. Temporary magnet is lost magnetism with external conditions. The permanent magnets never lost magnetism for external conditions. Properties of magnetism. Dipole. Magnet is a dipole with 2 poles. Pole strength. Pole of strength pole in a magnet. Magnetic length. The distance between the 2 poles in bar magnet. Magnetic moment. The product of pole strength and magnetic length. Magnetic flux. The group of magnetic force lines transmitting from north to south pole. Magnetic flux density. Total magnetic flux passing from north to south pole of bar magnet. Magnetic field. The field around the magnet until which is influence exists. A magnetic constant. The ability of a medium to permit magnetic flux lines. They are magnetic constant, medium and relative vacuum or free space. Susceptibility. The ratio of magnetism and applied magnetic field. The difference between the diamagnetic materials and paramagnetic materials, ferromagnetics and antiferro and ferric magnetic materials. The diamagnetic materials. Atomic dipoles are absent. Effects of the magnetic field are, we can see in our picture, without field and without a field. The dipoles are the in opposite direction. Spontaneous magnetism, no. Exchange, yeah. Exchanging of the coupling is yes. Sorry, no. Magnetic nature, weak. Magnetic field nature, weak. And magnetic flux, completely repelled. The susceptibility is negative and small. Magnetism is m is equal to 0. Effect of temperature, independent of the T, independent of magnetic field. Example for this condition is superconductor. Paramagnetic material. Atomic dipoles is present, and effect of magnetic field is, we can see in our picture that with field and without a field. Spontaneous magnetism, no. And exchange coupling, yes, are also no. Magnetic nature, partial weak or partial strong. Magnetic field nature, partial weak or partial strong. Magnetic flux partially attracted. In our pictures, like susceptibility, positive and small. Magnetism, m is equal to low. Effect of temperature, you can see in our picture, it is in the L shape in the curved. Example, alkali and transition of materials. Ferromagnetic materials and atomic dipoles are present, and effect of magnetic field, without field and with field. Spontaneous magnetism and exchange of the coupling is, we don't know. Magnetic nature, very strong. Magnetic field nature is very strong, and magnetic nature also very strong. Magnetic flux, very strong, attracted. Susceptibility are positive and large. Magnetism is high. Effect of temperature we can is equal to x is inversely proportional by 1 by T minus Tc. X is equal to C minus Tc. C is equal to the Curie constant and Tc is equal to the Curie temperature. Example, iron, steel, excuse me. Example is oxide, aluminous, MnO and FeO. Now, and synthesis of curves. The histories and curve shows a relation between the magnetic flux density and the magnetizing field strength. The curve is generated by the measuring the magnetic flux coming out from the ferromagnetic substance while changing the external magnetizing field. The picture that yeah. The magnetic flux density is increases when the magnetic field strength is increasing from the zero. When increasing the magnetic field, there is an increase in the value of the magnetism and finally reaches point A, which is called saturation point, where B is constant. Which with a decrease in the value of magnetic field, there is a decrease in the value of magnetism. But if B and H are equal to zero, substance or material retains some amount of magnetism is called retentivity or residual magnetism. When there is a decrease in the magnetic field towards the negative side and magnetism and also decreases at point C, substance is completely demagnetized. The force required to remove the retentivity the material is known as coercive force. In the opposite direction, the cycle is continuous where the saturation point is T, retentivity point is E, and coercive force is F. Due to the forward and opposite direction process, the cycle is complete, and this cycle is called the hysteresis curve. Advantages of hysteresis curve and small region and hysteresis loop is inactive of less and loss of hysteresis. Hysteresis loops provides the substance which the importance of retentivity and crush. Therefore, the way of the select the right material to make the permanent magnet is made simpler by the art of machines. Resolvable magnetism can be calculated from the BH graph, and it's therefore simple to choose the material from the electromagnets. Retentive and resistive. Retentivity, the amount of the magnetism presence when the external magnetizing field the removed is known as retentivity. It is a material's ability to retain and certain amount of magnetic property while an external magnetizing field is removed. The value of B at point B in the hysteresis loop. Correct. The amount of reverse external magnetizing field required to completely demagnetize it. The substance is known as the corrective of substance. The value of H at point C in the hysteresis loop. The soft and hard magnets. The differences. Hysteresis area in hard is high and soft low. Magnetize, magnetization easy and it is difficult. Demagnetization easy and difficult. Retentivity low and hard it's high. Corrosivity it's low and hard it high. Susceptibility in high. Susceptibility is low. Relative permeability is high. Relative permeability is low. Application is temporary magnet and hard magnets it permanent magnet. White's domain theory of the ferromagnets. The domain theory was proposed by the Winds in 1907. The domain ferromagnetic materials is divided into many regions. Each region is called domain. The size of each domain is 10 power minus 6 m. Each domain has a dipole magnetized in different directions. Ferromagnetic domains. The domain wall, we can see it. The domain wall is in the given arrow direction. The dipole is down, and domain is an empty space. The moment applications of the magnetic field, the moment is observed, and the applications of very strong magnetic field is rotation is observed. Origin of magnetic moment. Every atom magnetized with three types of magnet: orbit magnets and spin magnets and neutral magnets. So, thank you for thank you.